All right, do you guys remember when we talked about the penny problem and we looked at two different equations? I said if I gave you a penny and it was doubled every day for a maximum of 30 days, how much money would you have? Versus if I gave you $1 million up front and then every day after that I added an additional $5,000 to your pay. So these are our two equations right here. As you can see in the red, that's a linear equation producing that red linear graph. And over here, blue, that's our exponential equation, doubling every time, so growing really fast after about day like 22 or 3. So today what we're talking about is at what point does our exponential graph finally rise above our linear graph? Or in other words, when is it better to go ahead and take that exponential option, the doubling of the penny every day, versus taking that linear option? So really up until day, let's click on this and see, up until day 26.757, that is when it's really going to try to switch. And that red line is now going to be below the value of that blue line. So today we're going to be doing that algebraically, but I wanted to kind of give you some context on how that works. So your equations today are going to look a lot like this. They're going to say like 3x minus 2, and you may have, we'll go ahead and put f of x. Change our y to g of x. And we'll start with one that looks like that. Okay, so we're going to go back to the home screen here. And we're going to see at what point do these cross. So you can see these never cross, okay? So there is no point in which this linear function will ever be bigger than that exponential function. But if we play around with this linear function a bit, maybe change this to a positive 2. Let's go a little higher, a positive 6. All right, here we go. So now we see that at some point we are crossing over. So we are going to find algebraically today at what point does one line become higher or greater than the other line.